Okay, so we are going to go ahead and get started. Today we are talking again about triangle congruence proofs. The last several days, you wake up, the last several days we've been proving that one triangle is congruent to another triangle, and that had to be our last statement, right? Today, we are going to have to prove that one triangle is congruent to another triangle. But we're going to do that in the context of, we're going to use that to prove something else. When we first learned the definition of congruent triangles, we learned that all the parts have to be congruent before we can say the triangle A is congruent to triangle B, right? All three sides have to have the same length. All three angles have to have the same measure of degrees. Corresponding, right? Not all three. We don't do the same in each triangle, right? Then we learned those shortcuts. We could prove that one triangle, triangle A was congruent to triangle B, only proven three parts were congruent. They had to be specific corresponding parts, so we learned all about that. That was our side postulate, angle, side, angle, 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 side, and side, did I say side, side, angle, side. 4 of them, right? So now, they're going to ask us to prove one of the parts that's congruent, so we will have no way of knowing it's congruent, except we can prove the triangles are congruent. Once we know that those three parts are congruent, once we say triangle A is congruent to triangle B, now we know all the sides have to be congruent, and all the angles have to be congruent. It's very, very similar to what we've been doing today. We said one more step. Okay, one more little step. So this CPCTC stands for congruent parts of congruent triangles are congruent. So this is going to be a postulate. Once we can say, all right, triangle A is congruent to triangle B, that will be a reason to say any part that they ask us to prove is congruent. So we're going to write congruent parts of congruent triangles are, sorry, I think that should be corresponding parts, not details. Corresponding parts of congruent triangles are congruent. I didn't make that mistake in second period. I'll have to check with them. So, corresponding parts of congruent triangles are congruent. So C, so I want you to underline the letters and act like I'm underlining. C, T, C, T, C. Corresponding parts of congruent triangles are congruent. And the shortcut is CPCTC. Okay, jump right in and look at these two examples. So this is going to be example 1. This is going to be example 2. Yeah, that should be corresponding parts of congruent triangles are congruent, I believe. It says corresponding, I don't know why that says. I guess it's didn't get corrected. Okay. So let's look at the two triangles here. We've got triangle AMB and triangle AMC. Can we state that those triangles are congruent? So y'all look at it while I get the phone. Mrs. Zimmerman. We're in the middle of notes. Gives you time afternoon. Perfect. Thanks. Right. Okay, how much are we doing Thursday? congruent? How would we know? What do you think, Helen? Are they congruent or not congruent? Sorry? Well, let's look at it. Okay. So we have 4 postulates that we learned to help us decide, right? What am I forgetting? Angle side, angle. So, congruent side, congruent side, congruent side, we're sharing that one, and a congruent angle. So we have 2 congruent sides and 1 congruent angle. So the only possible one would be this one. That means the angle has to be the included angle, has to be in between the 2 sides. Is that angle the included angle? Ashley says yes. What do you think, Helen? It is, right? So congruent side, congruent angle, congruent side. Congruent side, congruent angle, congruent side. So we can say that they are congruent, side, angle, side. Right? So if we know that these 2 triangles are congruent, now we know all of their parts are congruent. So we're going to list the other sides and the other angles that we know are congruent. So we know 2 of the 3 sides in both triangles are congruent. So what is the side that we can now see that's congruent? Got it? What's the side that we have not marked congruent up here? There's one side of each triangle that we didn't mark congruent. Okay, so this side and this side are congruent. Right? This side is congruent and both. Where's the other side of each triangle? 1 side, 2 sides, 3 sides. So what's the side? BC is a segment that goes across both triangles, right? So when we're talking about 2 different triangles, it can't be BC. Sorry? So what kind of label is it going to get? Is it an angle, a triangle, a line, a segment? Not a line. Line goes on forever, right? Guys, we're making 3 triangles with segments. 3 segments that connect, right? So this is segment BM, what we talked about yesterday, is congruent to segment CM. So once we know that these 2 triangles are congruent, and we said they are, now we can say that segment BM is congruent to segment CM by CPCCC, because corresponding parts of congruent triangles are congruent. So let's talk about the angles now that we know are congruent. So we have 1 angle marked congruent in these triangles. So that leaves us 2 other angles. Some angle is congruent to some angle. We know there's 3 angles in every triangle, and we only have 1 marked congruent here. So can you give me another pair of angles, Miles? So M is a vertex for 2 different angles. So can we need 2 angles that are congruent to one another. I can't say angle M is congruent to angle M. It's not like a side, right? Say again. MBA, so remember that middle letter is going to, MBA would be 1, but it would be this one. Right, so we mark that one. So what's congruent to MBA? MC what? Yes, MCA. So MBA, angle MBA is congruent to angle MCA. Now there's 1 other angle, and it is at this vertex at M. So how can I give this angle and this angle's name? Charlie, can you help me? I need the other pair of angles that now we know because the corresponding parts of congruent triangles are congruent. What's the last angle that we can see is congruent here? A and C would be one of them, yeah. What's it congruent to? IMB. Yeah. It was not bad. I had the same other thing, which is good different. Well, tell me what you put. So CMA, yes, that would be fine. Okay. See, as long as the other one you put BMA. Yes, as long as you have them in the same order. Okay. And you have the vertex in the middle correctly. So good job. All right, so let's look at this second diagram, the second example. Do we know that these triangles are congruent? Are they congruent? Yes. What do you think, Thomas? Ashley's right, they are congruent. What's the postulate that we can use to say they're congruent? So one of those four things that we talked about. So, there you go. Good job. Good correct. Angle, congruent side, congruent angle. Congruent angle, congruent side, congruent angle. So yes, so we can say that these are congruent because of the side angle side postulate. Now we have to know that not just these three parts are congruent, the other three parts and corresponding parts in this triangle are congruent to this one. So we need two sides here. We only know that one side is congruent. Can you give me one side? The segment and the segment. Carlin, can you give me one of the sides up here that now, because of CBC, you know they're congruent? Okay. So we know this side is congruent to this side. Amari? Sorry? Oh, it is angle side angle. Thank you for correcting me. I said it and then I wrote it wrong. Thomas said it right and then I wrote it wrong. So if we know this side and this side are congruent, and now we know the triangles are congruent, what side do we know is congruent to this one, Harlan? Depends on how you're going to name this one. How do you want to name this one? Okay. And so then how will we name this one? Very good. DE. So you're going to name this angle is congruent to this angle, right? That's the corresponding angle on this triangle. So, and this really, let's put another bar there, another arc there. So now we know BC is congruent to DE. And I've got one other side. We need three angles and three sides that we can prove. Adine, how are we going to name the third side? So look at this one here. The only one that we haven't marked congruent, right? So we know this side and this side are congruent because that was a given. Now that we know the triangles are congruent, we can say we just have to match up corresponding parts, right? So if this side goes with this side corresponds with this side, so that means CA corresponds to EA. Okay? That's all we're saying. It's not any harder than that. Now we have two angles congruent here. So what's the last angle that we can say is congruent? What do you think, Tori? You know, B is congruent to D. CAB is congruent to EAB. What's the last angle that we can say is congruent to its corresponding angle? We're just looking for the one we haven't marked yet. So angle B is already congruent to angle D. B and C are in the same triangle too. It's going to be one angle on each triangle, right? Did we mark anything for angle C here? No. So what's congruent to angle C, Tori? What angle? Angle E. And angle E and angle C don't have to be named by three letters because there's only one angle there. Does that make sense, Niall? We can name, here we named them with three letters. Here we got to name them with just one, the vertex. Okay, just that one letter. All right, so let's see how we're going to use this in a proof. So if we have this diagram, our given parts. So now look up here. Look what our proof says. Our proof does not say we're proving a triangle is congruent, right? What we're looking to prove is that PQ is congruent to TS. We've never been able to state we can't use those sides to prove that triangles are congruent. We don't have any logic, no rules for that. But we can prove these two sides are congruent if we can prove that triangle QRT is congruent to triangle SRT. If we can say that this triangle is congruent to that triangle, then we can say that any part of each triangle is congruent. Does that make sense? Okay. So really, then our goal is the same as it was yesterday. We want to prove the triangle is congruent first, and then we add our last step. And our last step will be this, and I'm telling you it'll be by CT. We don't know all the other steps yet, but our last sequence will be this, and it'll be CT. So your best strategy is mark up your diagram, draw your picture, mark up your diagram, prove the triangles are congruent, and then fill in your proof. Okay? So the given information is that QR is congruent, segment QR is congruent to segment SR. So QR congruent to SR. Angle QPR is congruent to angle SPR. This middle letter tells you where my vertex is. QPR is congruent to angle SPR. Look at that middle letter. That's the vertex of that angle. We could have just said, they could have just said angle Q, or angle Q is congruent to angle C there, because there's no confusion about what angle we're talking about. But they did name that angle with 3 letters. Keep your head up, Dallas. Dallas, wake up. Take your head up. All the way. You need to stand up. You can stay late. Or don't put your head back in. That's right. Right? Alright, so I know these sides are congruent. I know one angle. Can I prove that any other part of these triangles are congruent? If you're not automatically thinking vertical angles when you see 2 lines cross, that's your mistake here, right? We have to, that has to jump out at us. This segment intersects with this segment. It creates vertical angles. This is a vertical angle, this is a vertical angle, but we don't care about those. We only care about the angles that are in our triangle. So here, this angle and this angle are congruent. So now we have one side congruent and 2 angles are congruent. So our postulate's got to be angle side angle or angle side to prove these triangles are congruent. So is it angle side or angle side angle? Well, angle side. Angle side, angle side. Exactly right. So now what we're going to do, send a proof. Send a proof. Don't do this one yet. This one has to be done last. Right, so on Alex, we have the option usually to send a proof. If they do not give you the option to send a proof, then you have to type those in. Okay, but I think they're going to give you those options. Don't do this one until last, and make sure you validate your last step. I keep messing that up. So, we're going to mark our given. Now, the other part, congruent part that we had to figure out was our vertical angle. So we have to say that angle SRT, that's this angle here, is congruent to angle QRT. I'm sorry, QRP. And the reason for that is vertical angles. So we've got a side, angle, side. So now we're going to say this triangle is congruent to this triangle. Actually, this one is congruent to this one. And the reason we're going to say is angle, side just like yesterday's assignment. But it did not ask us to prove that the triangle is congruent to triangle. We had to prove that the triangle is congruent. So now we can send this to proof. So this is the last thing we're going to do. When we send it to proof, it's going to pop up. Segment PQ is congruent to segment TF. And we have to say why. What's the partial we're going to use? CTCTC. Corresponding parts of the red triangle are congruent. Once we know that those three parts are congruent, now we know that the whole triangle is congruent to the whole triangle. So all sides are congruent to all sides. All angles are congruent to the corresponding angle. Does that make sense again? Yes? All right, we've got one other example. Y'all caught up with me? Okay. All right, now we're proving an angle is congruent to another angle. We're going to prove that angle STR, so that's this angle, is congruent to angle URT. So STR, that one's congruent to this one, right? Well, we don't have any way to know those are congruent. If we know that this segment and this segment were parallel, we could do alternate interior angles, right? It'd make it easier on ourselves. Well, they didn't tell us anything was parallel, so we can't use that one. But if we know that this triangle is congruent to this triangle, then we can say this angle is congruent. Because it has to be if the triangles are congruent. Open your eyes, everybody. Open your eyes. Let it talk. So let's mark. Segment RF is congruent to segment TU. Let's mark. Angle SRP is congruent to angle UTR. RF, TU. SRT. So our angle has to be at R, SRT. Angle UTR, remember this middle letter is the vertex. So be careful. Got to be here. UTR. Any questions so far? This is all old stuff, right? Well, if you go by the letters, yes, it does. The UTR is going to be on this side. If it says STR, it'd be on that side. Does that make sense? Here it says SRT, so it's on this side. If it says URT, it'd be on this side. Okay? So this angle, this vertex, is part of both triangles. This side is part of both triangles, and this vertex is also part of those triangles, right? So we're going to be careful that we're marking the right parts. And so do we know segment TR is congruent to itself by what property? Right, I think everybody's getting a little better at that. So now we have two sides and an angle. So two sides and an angle, we really only have one option. If it's side angle side, that means the angle is in between the two sides. Side angle side, side angle side. So now we know they are congruent by side angle side. Xavier, are you writing what we're writing? Come in here, Nathan. Okay. So once we know the triangles are congruent, we can say these are congruent by what? How do we know? What's the reason we're going to give? That's right, Morgan. C, T, C, T, C. So now we know everything. We just have to list it in our proof. Send a proof. Send a proof. Wait until the very last thing to send this one, right? This one can't go yet. Gotta wait till the last. Send a proof. It's going to populate those statements for you, and it's going to give the given reason for you. So we have a side and an angle. The only other side we mark is TR or RT, doesn't matter. And we know that that segment is congruent to itself by the reflexive property. So now we said we can prove this triangle is congruent to this triangle by SAS. So that's what's going to go there, and we're going to make sure we name our triangles correctly. If we say it's triangle SRT, we're going to say it's triangle UTR, right? This side is congruent to this side. This angle is congruent to this angle. It has to be in the same order. Yes. Not in the middle of this, we're almost done now. So we have two more things to uncover, and then we'll be done. Then you can go if you still need to. All right, so once we know that the triangles are congruent, now we get to send this to proof. Send that last congruent statement to proof. It's going to populate this for you, and you have to know to populate the corresponding parts of congruent triangles are congruent. Any questions? I think so, or it'll say corresponding parts of congruent triangles are congruent. So say one or the other. Right? It's going to give you a shortcut, or it'll give you the whole thing in there. You can scan and submit your notes. Reminding you, I'm not going to grade all notes anymore, but I will spot grade them. Well, probably going to happen about the middle of the quarter. I may go back and grade a couple. By the end of the quarter, I'll go back and grade a couple more. So they can count against you or for you. You should be scanning and submitting them. It's a good way to keep up with them. If you lose them, you'll always have them if you scan and submit them on Canvas anyway, okay? So let's go ahead and scan and submit and get your Chromebook out and work on Alex. You still have until 57. So by the time you scan and submit, you should still have 5 or 6 minutes to work. You scan and submit your notes, drop your phones back in your backpack, and then at least start your Alex assignment.